the existing panel entries are in violation of the National Electrical Code, specifically NEC 312.6. B. One which mandates that raceways enter an enclosure through a dedicated raceway hub or knockout. Furthermore, NEC 312.6. B. 3 prohibits entry through the backs or sides of cabinets unless approved by the authority having jurisdiction. Since the authority having jurisdiction is unavailable, this exception cannot be applied. When installing a new breaker panel, 2 options present themselves. Firstly, correcting the violations, or secondly, accommodating the existing conduits. The ideal solution is to correct the violations by installing raceway hubs or knockout plugs for the existing conduits and running new conduits from the attic to the new panel location. If correcting the violations is not feasible, accommodating the existing conduits is an alternative. NEC 312.6. B. 2 permits raceways to enter the enclosure from the back or sides if they are mechanically secure and provide suitable protection from abrasion. In addition, NEC 110.12. B. requires the enclosure to provide sufficient space for the conductors and conduit without overcrowding. To meet these requirements, utilize conduit clamps to secure the conduits to the enclosure. Provide adequate space within the enclosure for the conduits and wiring, and protect the conduits from abrasion using bushings or other suitable means. Correcting the violations is the recommended approach as it fully complies with the NEC. However, if accommodating existing conduits is necessary, ensure that all code requirements are meticulously met to ensure safety and code compliance. Remember that consulting with the authority having jurisdiction, once they become available, is crucial to verify their specific requirements and secure approval for the chosen installation method. Let's delve deeper into the specific National Electrical Code sections mentioned and provide a more detailed explanation of how they apply to this scenario. Firstly, NEC 312.6. B1, which discusses the entry of raceways into enclosures, specifies that raceways must enter the enclosure using a fitting specifically designed for that purpose, such as a raceway hub or a knockout. A raceway hub is a fitting that attaches to the enclosure and provides a secure and code-compliant entry point for the raceway. A knockout is a pre-punched opening in the enclosure that is designed to accept a raceway fitting. Entering the enclosure without using one of these methods, such as simply drilling a hole in the back of the enclosure, violates this code section. Secondly, NEC 312.6. B3 addresses the permissibility of entering enclosures through the back or sides. This section generally prohibits such entries unless specifically approved by the authority having jurisdiction. The rationale behind this prohibition is to ensure that the enclosure maintains its structural integrity and provides adequate protection for the conductors and equipment within. Entering through the back or sides can weaken the enclosure and create potential hazards. Thirdly, NEC 312.6. B2 provides an exception to the prohibition of back or side entries, allowing them if the raceways are mechanically secured and provide suitable protection from abrasion. Mechanically securing the raceways means that they must be firmly attached to the enclosure in a way that prevents them from being pulled or dislodged. This can be achieved using conduit clamps or other appropriate fasteners. Providing suitable protection from abrasion means that the raceways must be protected from any sharp edges or other potential sources of damage that could wear away the insulation on the conductors within. This can be accomplished by using bushings or other protective devices. Fourthly, NEC 110.12. B addresses the requirement for sufficient space within enclosures. This section mandates that the enclosure must have enough space to accommodate the conductors, conduit, and other equipment without overcrowding. Overcrowding can lead to overheating, damage to conductors, and difficulty in making connections. It is essential to carefully consider the size and configuration of the enclosure to ensure that it meets this requirement. When correcting the violations by installing raceway hubs or knockout plugs, it is crucial to select the appropriate size and type of fitting for the raceway being used. The fitting must be properly installed and tightened to ensure a secure and code-compliant connection. When running new conduits from the attic to the new panel location, it is important to follow all applicable code requirements for conduit installation, including proper support, bending radius, and protection from physical damage. When accommodating existing conduits, it is essential to carefully inspect the conduits to ensure that they are in good condition and free from damage. Any damaged conduits must be repaired or replaced before being connected to the new enclosure. The conduit clamps used to secure the conduits to the enclosure must be of the appropriate size and type for the conduit being used. They must be properly installed and tightened to provide a secure connection. The bushings or other protective devices used to protect the conduits from abrasion must be properly sized and installed to provide adequate protection. When determining the appropriate size of the enclosure, it is important to consider the number and size of the conductors, the size and type of the conduit, and the amount of space needed for making connections. The enclosure must be large enough to accommodate all of these components without overcrowding. In addition to the specific National Electrical Code sections mentioned, it is also important to comply with all other applicable code requirements for electrical installations, including grounding, bonding, and overcurrent protection. It is always recommended to consult with a qualified electrician or electrical inspector to ensure that the installation is code compliant and safe. Here's some more detail on the practical steps involved in each option. Firstly, correcting the violations. This involves a few sub-steps. Firstly, identify the existing conduits that are entering the panel improperly. These are the ones that are not using proper knockouts or hubs. Secondly, for each of these conduits, determine the size and type. Is it 1/2 inch, 3/4 inch, or some other size? Is it rigid metal conduit, electrical metallic tubing, or PVC? You need to note this to select the correct fittings. Thirdly, purchase the correct knockouts or hubs for your new panel that match the size and type of conduit. These are readily available at electrical supply stores. Fourthly, carefully remove the existing conduit from the old panel. This might involve cutting the conduit if it's glued in place in the case of PVC. Be careful not to damage the wires inside. Fifthly, install the new panel and install the knockouts or hubs in the correct locations. Sixthly, reroute the conduits to enter the panel through the new knockouts or hubs. This might involve bending the conduit or using couplings and short pieces of conduit to make the connections. Seventhly, securely fasten the conduits to the panel using the appropriate connectors. Make sure the connections are tight and secure. Now let us dive into the option of accommodating existing conduits. This also involves a few sub-steps. Firstly, as before, identify the conduits that are entering the panel improperly. Secondly, carefully inspect the conduits for any damage. If they are damaged, repair or replace them. Thirdly, use conduit clamps to secure the conduits to the back or sides of the new panel. These clamps should be appropriate for the size and type of conduit. Fourthly, install bushings or other protective devices where the conduits enter the panel to protect the wires from abrasion. Fifthly, make sure there is enough space inside the panel for the conduits and wires without overcrowding. This might involve using a larger panel than you originally planned. Sixthly, when wiring the panel, be extra careful to avoid damaging the wires as they pass through the conduits. Now let's discuss some additional considerations. When working with electricity, always turn off the power at the main breaker before starting any work. Secondly, if you are not comfortable working with electricity, hire a qualified electrician. Thirdly, always follow all applicable building codes and regulations. Fourthly, when in doubt, ask for help from a qualified electrician or electrical inspector. Here are some specific product recommendations to help achieve code compliance and safety. Firstly, for conduit clamps, look for UL-listed conduit clamps that are specifically designed for the type and size of conduit you are using. Brands like Thomas & Betts and Eaton offer a wide variety of options. Secondly, for bushings, use UL-listed bushings made of plastic or metal to protect the wires from abrasion where they enter the panel. Again, Thomas & Betts and Eaton are reliable brands. Thirdly, for knockout plugs, if you need to close up unused knockouts in the panel, use UL-listed knockout plugs of the correct size. Fourthly, for raceway hubs, if you are using rigid metal conduit, consider using raceway hubs for a secure and code-compliant connection. Here are some practical tips for working with PVC conduit. When cutting PVC conduit, use a PVC cutter or a fine-toothed saw. Make sure the cut is clean and square. When gluing PVC conduit, use a PVC primer and cement specifically designed for electrical applications. Follow the manufacturer's instructions carefully. When bending PVC conduit, use a PVC bender or a heat gun. Be careful not to overheat the conduit, as this can damage it. Here are some practical tips for working with electrical metallic tubing conduit. When cutting electrical metallic tubing conduit, use a pipe cutter or a hacksaw. Make sure the cut is clean and square. When bending electrical metallic tubing conduit, use a conduit bender. Be careful not to kink the conduit. When connecting electrical metallic tubing conduit, use fittings specifically designed for electrical metallic tubing conduit. Make sure the connections are tight and secure. Let's talk about some common mistakes to avoid. Firstly, do not overload the panel. Make sure the total load in the panel does not exceed its rating. Secondly, do not use the wrong size or type of wire. Make sure the wire is appropriate for the circuit's amperage and voltage. Thirdly, do not make loose connections. All connections must be tight and secure. Fourthly, do not neglect grounding and bonding. Grounding and bonding are essential for electrical safety. Fifthly, do not work on live circuits. Always turn off the power before starting any work. In summary, upgrading a breaker panel requires careful attention to code compliance and safety. By following the steps outlined above and avoiding common mistakes, a safe and code-compliant installation can be ensured. Remember to consult with a qualified electrician or electrical inspector if you have any questions or concerns. We'll now address some frequently asked questions about breaker panel upgrades. Firstly, how do I know if my breaker panel needs to be upgraded? Some common signs include frequent tripping of breakers, flickering lights, and the inability to add new circuits. If your panel is old or damaged, it should also be upgraded. Secondly, can I upgrade my breaker panel myself? While it is possible to do it yourself, it is generally recommended to hire a qualified electrician. Electrical work can be dangerous, and it is important to ensure that the job is done correctly. Thirdly, how much does it cost to upgrade a breaker panel? The cost can vary depending on the size of the panel, the complexity of the installation, and the location. Get quotes from several qualified electricians to compare prices. Fourthly, how long does it take to upgrade a breaker panel? The time it takes can vary depending on the complexity of the installation. A simple upgrade might take a few hours, while a more complex upgrade could take a day or more. Fifthly, what permits are required to upgrade a breaker panel? Most jurisdictions require a permit for electrical work. Check with your local building department to determine the specific requirements in your area. Sixthly, what are the most common national electrical code violations related to breaker panel upgrades? Some of the most common violations include improper wiring, inadequate grounding, and failure to provide sufficient working space around the panel. Seventhly, how can I find a qualified electrician? Ask for referrals from friends, family, or neighbors. You can also check with your local Better Business Bureau or online directories. Make sure the electrician is licensed and insured. Eighthly, what questions should I ask an electrician before hiring them? Ask about their experience, their qualifications, their insurance coverage, and their pricing. Get a written estimate before starting any work. Ninthly, what should I do if I have a problem with my new breaker panel? Contact the electrician who installed the panel. If you are unable to reach them, contact another qualified electrician. Tenthly, how can I maintain my breaker panel to keep it in good condition? Periodically inspect the panel for any signs of damage or corrosion. Test the breakers to make sure they are working properly. Keep the area around the panel clear of obstructions.